What's up everybody? In this video I will explain how to create a RAG agent using LangGraph. The agent will be able to answer financial questions about Apple using Apple's 10K report filed to SEC. The prerequisite for this tutorial is that you know little bit about what RAG is, how it works, and you have little bit of background in LangGraph as well. As you can see on my screen, I have already started Jupyter Notebook where I have kept the code for this tutorial. At the beginning of the notebook, I have highlighted the important sections of this tutorial. So in the first section, we will load the LLM. So we will be using an open source LLM Llama-3.3 with 70 billion parameter version for this tutorial. And that open source LLM is freely available through Groq API. So Groq is an open source LLM service provider and we will use it to access our LLM. In the second section, we are creating the retriever tool. So for retrieving the relevant chunks of the data, we will use this retrieval tool in our LangGraph graph. So over there, we will load the data, which is our PDF report of Apple's 10K report, which is filed to SEC. Then we will insert that data into the vector store. So we will be using a ChromaDB vector store. And then we will create a retriever tool from the data which is stored in the vector store. We will be storing embeddings of the data over there, embeddings of the chunks of the data. And then we will bind the retriever with LLM. So we will bind this tool with LLM. So LLM will use that tool whenever it needs to. And then we will define the RAG agent, the class we will define. Well, we will have total code of our RAG agent that will be in the fourth section. And then in the fifth section, we will send various queries to our agent and check whether our RAG agent is working as we expected or not. At the beginning of the notebook, in the first cell, over here, I am simply loading the environment variable. So I have kept the Groq API key in the current .env file, which is kept in the current directory of this particular folder. And from there, I am loading the Groq API key. And we will use this Groq API key to access our LLM through Groq. In the first section, I am loading the LLM which we are going to use for this tutorial. For that, you will need to install this particular package langchain-groq, and from there you will import chat groq. As you can see, we are importing chat groq, and we will set the API key, which is Groq API key, which is loaded from our environment variables. And the model we are going to use is Llama 3.3 and 70 billion parameters version we are going to use. So that's our model. And over here I am using an open source model, but you are free to use any other model as well. If you have a OpenAI subscription, then you can use LangChain_OpenAI. You will need to download that, or you can use also Anthropic or any other LLM provider if you are feeling that you are comfortable using that particular LLM. Then feel free to replace this open source LLM with that one. And then once you have loaded the LLM, you can simply send a query to it by using this method invoke on it. Over there you can give a simple string over there. So over here I am simply asking hello, how are you, Llama 3, and the response from this chat model is AI message, as you can see. And in that AI messaging content, we have a response from the chat model that I'm doing well, thanks for asking, and how can I help you today. And there is also some other response metadata about the token usage. So that's how you can load LLM. So after loading the LLM, the next important section is to create a retrieval tool. Now this section has 3 subsections, which I will go one by one. So first of all, we will load the data. So for that, we are using a PyPDF loader, which is available from LangChain_community library of Python. From there is a document loader, and from there you can use the PyPDF loader. And I have kept this PDF Apple 10K 2023. So it's a 10K report of Apple's financial for the year 2023. And it is available as a PDF file, and it's available freely on internet. You can download it. It's a public report and have access to everyone. So that you can load a PDF loader, and then you can simply call this load method over it, and it will return you list of pages. So each page is a individual page of that particular PDF. And as you can see, we have 80 pages in this particular PDF report. And you can also see the content of an individual page. So I am over here displaying the fourth page of this document, and as you can see, each individual page is a document object, and over there is a metadata, and then in the content, page content, as you can see, the text of the total page is present over there. So yeah, so that's how you can load the PDF report into the memory. Now once you have loaded the PDF report, now we in this below cell, we are splitting it into the chunks. So before loading this PDF report pages into our embedding database or vector store, we will first split it into the chunks, and for that we are using this sentence transformers token text splitter, and we are creating an instance of that class, and over there we have given this model name. So sentence transformers is a famous Python library that provides various LLMs that are trained to create an embedding of the text, specifically trained to create proper embeddings of the text. And one such model is all distill Roberta v1, which is available on this website, sentence transformers, the document of sentence transformer. So we will create an instance of this particular LLM. So what this will do, whatever is the tokenizer of this particular LLM, that tokenizer will be used to split our pages of our PDF report. So then we are calling this method split documents on our text splitter, and over there we are giving the pages. So as you can see, we have 80 pages in our document, and these split pages are the pages of that 80 pages which are split further. And as you can see, total chunks are 170. So our 80 pages are split further into the small chunks. And for those of you who don't know, this model all distill Roberta v1, it has a tokenizer which generates chunks of size 512 tokens. So each chunk in this split page, so individual page in this split page is a chunk, it will have a size of 512 token. So that will be the size of each individual chunk present over here. So that's how it splits our 80 pages further, and these chunks we will insert into our vector store. Now in this section we will load those chunks which we created in the previous section into our vector store. So for this tutorial I have decided to use a ChromaDB vector store, and as you can see, I have a few imports over here. So let me walk you through the code. So first of all, I am creating an instance of persistent client from ChromaDB. So I'm creating a persistent client. What this client will do is that it will help us create a collection in the Chroma vector store, and this is a persistent client, so the data will be stored to the disk in this path Apple 10K 2023, and it's in the current directory. In the current directory, the folder name Apple 10K 2023 will be created, and inside of that there will be a file, SQLite DB file, where the embeddings of the chunks and their text will be stored. And then in the next line I have defined the function. So this function will be used to create the embeddings of the chunks which will be stored in the database. And again, if you notice, it's the same model, distill Roberta v1, and that model is available from sentence transformers library. So we will use same LLM to create the embeddings. So that's our embedding function. And then using a create persistent client, we are calling this method create collection. So this vector stores have a concept of a collection where the embeddings and the text of those chunks are stored. So we are creating that collection. I have given the name like Apple 10K 2023, and this collection will be stored in the database. And the embedding function is distill Roberta. So this particular LLM will be used to create the embeddings of the various chunks. And I have set get or create to true. So what this will do is that if this particular collection is already present in the database, then it will retrieve it, or it will create a new one. So because we are using persistent client, if you rerun the code, next time the code will already have this collection in the database. And then this particular line of code, collection.add. So after you created collection, you simply call the add method on it to add the documents to the database. So run this particular line of code only once, collection.add. If you rerun it again and again, it will keep on adding same documents to the DB. So keep that in mind. And in documents, we have given a list of documents. So we are simply looping through split pages for each doc. And page content is the text of that particular chunk. So that's what is the documents. IDs are simply text. So I'm simply looping through split pages with the index. And as you can see, chunk 1, chunk 2, chunk 3, that will be the IDs. And metadata, if any metadata is present in this split pages, because even split pages, individual split pages are also an instance of document. So if some metadata is present, like whatever is the page number or something, that will be added over here. The next stage after inserting those text chunks into the vector DB is to create our retriever tool. So for that, I have defined a simple function called retriever tool. This function takes a user query as input. So whatever query is given by user, that will be going over there. Or if LLM decides to modify that query, then that will go over here. And over here, I'm simply querying our collection, which we created above. Over there, I'm giving the input query, so input text, and end results is set to 5. So the 5 chunks from our total, some 170 chunks, the 5 chunks which are most relevant for answering this input query, those will be returned as a result. And then I'm simply joining those chunks to new line character. As you can see over here, I'm calling join method on this 3 new line characters, and from results I'm retrieving documents. And in order to create this particular function into LangChain structured tool, we can simply annotate it with @tool. Once you annotate any function with annotate this @tool, this retriever tool will become a instance of structure tool, and then you can call method invoke on that instance. So now that invoke method is available because it's instance of structure tool now, and over there you can give any query. So for testing purpose, I ask it like, what is the revenue of Apple? And this is the long string that it returned. And if you notice closely, you see 3 new line characters. So I think this will be the first chunk, and then this will be the second, and so on. So five chunks are combined. In these 5 chunks, one of them will definitely have a revenue of Apple. If you look at this text over here, it seems that there is information about revenue. So there are net sales products, so there will be information about the revenue over here. So that's how you create a retriever tool. So after we have created a tool, or even list of tools, in our case there is only one tool, we need to bind those tools with LLM. So LLM has knowledge about those tools, so it will know when it need to use those tools. It can call those tools. So for that, the process is pretty simple. You simply need to call bind tools method on this LLM instance. Over there you need to provide tools, so list of tools, and it will again return an instance of LLM, but this time it will be aware of the tools choices that it has. So if it needs to answer if it needs to use these tools to answer some question, then it will use those tools. And tools choice is auto, which means that there will be times when it might not need to use tools. Then yeah, so over here, as you can see, once you have LLM with tools, you can simply call the invoke method on it. So over here I'm simply calling a simple query, what's up. And for this query, if you understand, the LLM do not need any tool to answer this query. So as you can see, response, AI response, if you check the content of that AI message, it's answering the tags that it seems that you're trying to start a casual conversation. I am here to help any question or provide, and how can I assist you today? Now this LLM with tools has another attribute, tool calls, where the list of tool calls will be present. So if a LLM needs to use any tools, then they will be available over here. So let's try that. So next I'm calling our LLM, but this time I'm asking it like, what's the revenue of Apple? And now our LLM knows that this time it will need to use that retriever tool where the information about the revenue of the Apple will be available. So this time if I print the content, as you can see, content is empty. There is no content. But if I check the tool calls, over there you can see that there is a retriever tool. And we can also see in arguments, it has given this should be the argument of the tool, that query should be revenue of Apple. As you can see, our LLM did modify the query a little bit. I asked it what's the revenue of Apple, and it said that this revenue of Apple. So this revenue of Apple string will be going inside our tool to retrieve the relevant sections from that particular report. So that's why we need to bind tools with LLM. Alright, so now we are in the most important section of this tutorial where we will define our RAG agent. So first of all, I have a sample image which kind of shows the workflow of our particular RAG agent. So and as you can see from the image, this particular graph has 1, 2, 3, 4 nodes. First is the start node, then there is a Llama-3 node, which is for our LLM, and then there is a retriever tool node, and then there is an end node. And from start there is a edge to Llama-3. So whenever query comes, first it will go to LLM, and then the LLM has two dotted lines to retriever and fall. So LLM will decide whether it needs a retriever to retrieve some documents to answer user query. Then it will send the control flow to retriever, else it will answer the query and return it. But let's say that it needs some chunks or some parts of the report to answer the question, then the control flow will go to retrieval node over here. From there the relevant documents will be retrieved, relevant chunks, and those chunks will be returned back to our LLM. Now our LLM has original query, the relevant chunks, and it will be able to answer the question. So now it will return the response to the user and end it. And it might happen that even after retrieving chunks, the LLM might need more information. It might modify the query and send that new query to the retriever again to retrieve more chunks, relevant chunks. So it can go into this loop. But once it has all the relevant information to answer the user query, it will generate the response and return it, and that will end the workflow. So that's the workflow of our RAG agent. Now let me explain you the code that implements that particular workflow. So at the beginning there are few useful imports, and I will explain you the imports when we use them in the code. So the first class over here, this is the very important class, and as you can see, this is the agent state. So agent state is what? It's a kind of an object that will be passed between node, and it will have all the information about the agent's current progress. You can say that it will have all the information about agent's progress, and you can define any kind of object. But over here we have defined it as a dictionary. So as you can see, this class is extending type dict, which is imported from typing Python library. And that particular dictionary, so this agent state is a type of a dictionary. It has one key, messages, and the value of that key is list of any messages. Now any message can be either the system message, either the human message, it can be tool message, or it can be also AI message, which is a response from our LLM. Now as you can notice that I have annotated this list of messages with this function operator.add. So what is the usage of this annotated? Now the default behavior of the graph is that whenever the particular node returns any response, so the response from the node will again be the object of this type, agent state. So that response will again be some list. Now that list will override whatever is the value present in these messages. But we want the history of messages, and we don't want to lose the previous messages. So that's the reason we have annotated it with operator.add. So it won't override it, the existing list of messages. What it will do, this operator.add will keep on adding messages to the end of the list. So initially this will be empty, like as you can see, messages, and this will be empty list. but whenever user query comes, that message will be the human message, it will be appended, and then some AI response, that message will be appended. So all of this will come through different node, but the nodes won't override it, this list. They will keep on appending to that list, and for that we need to use this annotated and that operator add function. And that's the state of our agent. So that's very important class, and our agent is defined as this particular class RAG agent, and the total code of the agent is over here, the graph code of the graph. And as you can see in init, it takes 3 arguments: model, tools, and if any system message you want to provide, the default is that you are a helpful assistant. So first we are setting the system message, then we are defining self.tools. So I'm looping through tools, and this is a simple dictionary which is mapping from tool name to actual tool, and this will be useful to call the tools because the response from LLMs is a tool name, not actual tool. So we will use this mapping to call the tools, and then we are calling model, the input model dot bind tools. We are simply mapping it over here, as you can see. So now this self.model is the model with tools. Next we are creating the graph. So in order to create a graph, we need to create an instance of state graph, and over there, as you can see, we have provided agent state, which is this one, the object we created. And then first I have added 2 nodes to our graph. So the 2 important nodes are Llama-3 and Retriever. So Llama-3 and Retriever, these 2 nodes are 2 important nodes of our graph, which I have added over here using this add node method. And Llama-3 handles using this call LLM method. So let me explain call LLM method. And as you can see, this method takes as input the state, the agent state as input. So from state we can retrieve the list of messages. So those are the messages, as you can see. It will be the list of messages, human messages, and so on. And if there is any system message, then we append it to the system message. As you can see, we are creating instance of system message plus messages. So the system message will be added at the beginning, and then I'm simply calling model with those messages, and that will return a response. And if you remember, those are the AI messages. So that only AI messages is getting returned from this particular message. As you can see, it's returning dictionary with the messages key, and the value is only AI message response from the model. So what will happen is that this particular AI message will again be appended to the list of messages to our states. Initially the human message will be appended, then this AI response will be appended. So whenever you call Llama-3, it will be handled through this method call LLM, which will return AI message. Then there is a retriever node, and that is handled using take action method. So take action method is over here, and again it takes as input state, and from that state we are retrieving messages, and we are retrieving the last message. So last message will most probably be the AI message, and from there we retrieve the tool calls, because first of all, as if you remember, the flow first go to LLM and then it goes to retriever. So last message will be AI message when we are going to execute this take action method. So from there we retrieve these tool calls, and if there are any tool calls, so in some scenarios when it needs various chunks to answer question, these tool calls will be present. So this for loop simply executes that tool call. As you can see that it loops through tool calls, and there is some checks, and then over here self.tools is a dictionary. From that dictionary we are giving t of name. So this will retrieve the actual tool, and then we can invoke it with the arguments. So this I explained earlier, if you remember, and then we will get the response from that particular tool. And if you remember, the response from the tool in our case is the retriever tool. It will be a long string for our case. So what we will do, we will create an instance of tool message where tool call ID will be their name, and the content will be the string of result. So whatever is the response from tool, which is a string in our case, and all those tool calls will be appended into the results. So in our case, mostly there will be only one tool call, but then can be more than one tool calls as well. So these results will be list of tool messages one after another. So after AI message, this tool messages will be appended to our list of messages. As you can see, this message is only return results, and those results are list of tool messages. So after these two nodes are defined, the next part is to define an conditional age from Llama-3 to retriever and end. So this conditional age, which is based on a condition that whether there is any tool call or not, and that condition is handled through this method self.existAction. So what this existAction function does is that it again takes state as input, and from that we retrieve the last result, and again last result will be AI message. And if that AI message has any tool calls, so if the length of the tool calls is greater than 0, so if there are any tool calls, then this function will return true, else this function will return false. So if there are any tool calls, then it will return true and the control will go to retriever, else it will end. So that's this conditional age, that if there is a tool call, then go to retriever, else go to the end. And then we are adding the age from retriever to Llama-3. Now this age is important because once we have gone from Llama-3 to retriever, the graph again needs to transfer control to the Llama-3 back, that whatever chunks are retrieved, send it back to LLM, and the LLM will generate the response based on that chunk. So that is that particular edge over here. And I have set the entry point to Llama-3. So this is important. We need to tell the graph where we are starting. So the control flow will start from Llama-3. So whenever query comes, first it will go to Llama-3. And that's our graph. So once graph is defined, you need to compile it and set it in self.graph. So that's our agent. Now over here I have declared the agent, but over here I have created an instance of our agent. So as you can see, agent, and over there I have given Llama-3. I have given list of tools. So in our case it's a simple retriever tool. And system prompt, I have defined a simple system prompt that you are a smart AI finance assistant and use the retriever tool available to answer questions and so on. So it's a simple system prompt which I have given over here. And this is the agent we will use to answer various queries about the Apple document, Apple 10K report. And as you can see over here, I have explained that once you have declared an agent, how you can plot it. So you can call agent.graph, and there is a method named getGraph, and on that method you can call this draw png function, which will create a png, and you can display it in the notebook. So as you can see from this image, it's the same image as the one I explained earlier about the control flow of our agent. Alright, so now that we have declared our agent, next let's go ahead and send various queries to it and see how it's performing. So for sending the query, we can declare an instance of human message or content. We can specify whatever query, and that list we will be giving this messages list, which will be mostly human message, to our agent. And in order to send queries to agent, we need to call agent.graph.invoke method, and over there we need to give this dictionary messages with list of messages. So this will be the first message which will be going to our graph. And if you see this particular dictionary, it's an instance of agent state. So that's how we need to provide an input, and then we will get the result. So if you see from result will again be the agent state. So we retrieve the messages and we retrieve the last messages. So result will have all the messages, but the last message will be the response from the chart from the agent. And for this particular query, as you can see, it's a simple query, hello, how are you? For this the tool does not need any, the agent does not need to call any tool. So if you see the content, I am doing well, thank you for asking. Is there something I can help you with, or would you like to know something about Apple's financial from the 10K report for 2025? Yeah, so it's guiding us. And so yeah, so let's go ahead and try that. So now I have sent again another query, and this time I have asked it what is the total revenue of Apple. Now for this particular query, it will need to call our retriever tool. So again, the result, as you can see, when I call this particular query, you see that it's printing that calling this tool particular to retriever tool, and this is the input query to that tool, that total revenue of Apple from 10K report 2023, and tool executions complete. So these are the debugging messages which were present in the code. So these are over here, the tool executions complete and whatever the tool name calling this particular tool. So that take action function which executes retriever, that got executed and it printed some debugging message. And if I print the result, if you see this time, so I have printed the result, it's again a dictionary. And if you see the content of this dictionary, so it's a list of messages. First is the human message, our input, what's the revenue of Apple. Then the response is AI message with empty content, but there is a tool calls in this one over here. As you can see, there are tool calls with this total revenue query function. So there is a tool call, and then the tool actually got called. As you can see, tool message is appended. This string has information about the revenue of them. And after that tool message, the last message is again AI message, and there we have a total revenue of Apple, this million. So you can retrieve the final response, which will be the last message in this list of messages. And as you can see, the total revenue of Apple is 383 and 285 million, so 383,000 millions. You can go ahead and check this on the internet, that what is the revenue of Apple, and you will find that over there it's written that around 383 billion, but over here we have in millions, so it's the same. We have 383,000 million, so it will be 383 billion. So our model was able to find the important information from that agent response in the retriever tool. So let's go ahead and try a few more queries, that what is the revenue of Apple by regions. As you can see, again we are invoking our agent, Apple revenue by region 2023, that's the query, and here is the response. So what is the revenue of US, what is the revenue of China? So 138 billion from US, 72 billion from China, and from other countries 172 billion, and total net sales is 383 billion. So that's the revenue of Apple. Tell me about the list of services provided by Apple. So you can go ahead and ask the many different questions about the Apple's financials. The 10K reports are very comprehensive and has a lot of information about company, and it's filed annually to SEC. So you can ask a lot of questions. And as you can see from the response, that these are the services provided. They provide advertising services, they have Apple Care, they have cloud services, digital content, payment services, and these are the various parts according to various segments. As you can see, various regions, actually Americas, Europe, and so on. Next I'm asking, tell me about the legal proceedings of the Apple. So that information will be present in the tool as well. And if you notice this time, if you see, earlier we had only one tool call, but if you check over here, you see this time our agent went into the loop, and if we have two tool calls. If you see, the first time it went ahead with the query legal proceedings of Apple from 10K report filed for the year. So this was the input query, and it got some context, but the LLM thought that it's not enough, so it again sent the control to the retriever tool, and this time again it sent a query that Apple legal proceedings, and I think that would have retrieved even more relevant context. So as you can see, it called it the tools 2 times this time. And yeah, and then there is a response that based on the 10K report file for the year, these are the two legal proceeding. So they have some problem with Epic Games and some problem going on legal proceeding with Massimo. Next I'm asking, what is the net sales of Apples by segment. So you can also check that there are 200 billions of iPhone sales. So the majority of revenue comes from iPhone sales. from 383 billion. Half of that is coming from iPhone, and second is Mac and iPad and so on. There's some wearables, home and accessories. This will be Apple Watches and other services like Final Cut Pro and other services that they provide. So from that 85 billion has come. Next, I'm asking what is the net sales of Apple by products and services. So you can ask that as well. And this response is same as almost previous ones, that these are their product: iPhone, Mac, iPad and wearables. Then so it organized it into the sections of products and services. Next, I'm asking it about tell me about the operating expenses of the Apple. So for this one, it went into the tool calls 3 times. As you can see, might not have been able to retrieve the enough information on the first call, so that's why there are 3 calls. And there is a response that the total operating expenses are this, which is 7% increase from 2023. So it did a calculation over there as well. Yeah, and the last query is tell me about Apple's assets. So you can ask about Apple's assets as well. And the response is that as of September 30, 2023, Apple's total assets were 352 billion. So yeah, that's our agent. That's how you can create a RAG agent using LangGraph. If you have any doubts or any queries, then please feel free to let me know in the comment section, and see you next time.